Everybody should know the differences between design verification and validation fields in order to do this one as a fundamentals of a design verification engineer. In a fundamentals of design verification, the process of design and the verification and the validation are very important. And my name is Omsi Krishna Masetti. The topic is discussing about by me, and I am a PSU graduate student. I am doing this lecture videos as a volunteer so that everybody should get idea on this one. Let's go for the deeper dive of these topics. So our agenda is going to be I going to define some definitions of design, verification and validation fields, and we'll go discuss on the key differences and real with the real world examples on that, and with industry experience the importance of these things will be discussed. So what is design? So when everybody say what is design, it is going to be an architecture of a block diagram of a system. Okay, so design is the process of defining how a system, product or a software would be built. It includes the architecture, components, infrastructure, interfaces and data necessary to meet the specified requirements. The goal of the design is very simple. It's a blueprint or a plan that satisfy all the system or the product requirements. For example, if I take a design of a mobile app user interface and the backend logic, so that if I take a mobile app application, I should know what to design, on what basis I have to design. It's like an flow of architecture. It's like a creation of schematics for the electric circuit. Suppose if I take an electric circuit, there are so many ICs which are connected in the form of VLSI, very large scale integrated circuits. So in that, if I take a big in the big picture, if I zoom, the transistors are arranged in a design. So these are very crucial for an architecture. So for that one, what we are going to do is we do have an RTL testing. So RTL is a design thing. Okay, in that we will use the coding for Verilog, System Verilog and VHDL. So we will go on and do our design testing by using these codes, and we will write a function analysis on this. So this is going to meet the specification. If it is going to meet the specification, then we are going to be good. Okay, otherwise we have to check what are the things that is happening. So writing an RTL for an FIFO or a CPU ALU is like one of the example topic which we can go on and discuss. Suppose if I take an CPU ALU, so there are some components in that, right? So the four components are going to be have a Verilog code for which we are going to do the specification. So if it is meeting the input as an output, so then it is going to be fine. Otherwise we need to change our design, or we need to update some of the specifications which has given by the client. So these are the things, like the specification is given by the client, and from that we are going to design an RTL design. From that we are going to get a net list. So this is the steps used in the design process. So in verification, it ensures whether the product was built correctly according to the design and the specification. It's about confirmation. Like the questions I can build on this is did we build the product right? So to ensure the product means the design specifications, we are going to do some testing on that. Okay, in methods of testing we might use simulation, assertion, formal verification and UVM test benches. So there are some test benches, that is a thing which we will have in a tool. In the tool we are going to work on that. focuses mostly on functional errors before tape out. So tape out is the process, it is going through the post silicon validation. So there these steps are like in the parallel. Okay, first is the design, and next will be the verification, next and that will be the validation. So if you take the example like running testers to ensure the software may function match the design documents, and also checking a circuit board layout against the electrical circuit design. So there are some specifications might be added. So with the exhaustive testing cases, we are going to test each node by giving some of the values. Suppose there is one more example mentioned in this PPT, that is the test bench shows FIFO overflows incorrectly. Suppose if it is going to overflow, so there is a bug, so we have to fix the design with this topic. So these are the steps involved in the verification. Okay, so first thing will be the test bench, we have to write it, and this will be implemented on the RTL design. So from that we are going to have a scoreboard, monitor or the checks. So from that we are going to check whether the verification is done properly on the particular design or not. So we are going to get an expected output, but there is an for the input which we are going to driven on this, for the cycles which is it is going to be the simulation. So there is a process called simulation that is going to most helpful in this verification process. So next thing we'll go and discuss with about validation. So it is the thing which ensures the end product meet the customer requirements. So without this validation process, the end product is going to discard it directly to the garbage, because if we are going to 100% sure we validated the device, then only we can sell the product in the market. So that's the thing, like without having the needs required by the user, if we are going to send it in the market, it's not going to make any difference. So it has to need the correctness. So for that, this validation is the wonderful step. Did we build the product right? So in order to fulfill the intent use in the real world, we will check this one as a final step. The methods which we will use these days are UAT, field testing, beta testing, and customer feedback. The first customer feedback is also one of the important, which will be the key role on the last of this topic. Suppose in the examples we can take as running the chip in actual board system to check if it is work as intended. Suppose there are number of chips. Suppose let's take in 100 chips are there in are assigned nicely or parallelly or serially. So those are connected. In that one of the chip is not working because of this validation technique. Maybe we found out the one of the chip which is not working, and because of that we might discard it. This is going to be $1 million business. So if you are going to have a small problem in one of the device, the customer feedback might be completely wrong and might be upset. So this might be not at all good for anyone. So this is the validation step. It is very 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 important. Suppose if we have any medical device performance, so in a clinical setting up, so this will be also one of the example you can have it. These are the steps involved in the validation. So we will take the chip or board and we will run in the real applications, and from there we will get an feedback, which is by us or it is by the user who are going to use this one. They are going to give us the feedback. So let's go some crazy differences on these topics, the design, verification, and validation. There are some aspects on which we can go on now, like if you take on the focus of these things. So design is built as a build system as per specifications. So as per the specifications we are going to put on the design, it focuses mostly on the design specifications. Okay, and the verification is going to just check the correctness of the implementation. How we are implemented, that is going to be checked by the verification. and the validation is mostly focuses on how the product is meeting the needs of the customer or not. So if it is not going to meet the requirements of the customer, it is going to be discarded directly. And when we are going to use this design is an RTL coding staging. And in the verification is nothing but a pre-silicon validation, so we will use simulation and a formal as in verification tools in these topics. In the validation we will have a lab testing, that's a physical thing which is a post silicon. So once the silicon fabrication is done, we are going to do this step in the last. Suppose like what we have to question in these differences are like in design we will question what to build. Okay, like it is a first step and this is the scratch step of the process, like what design you want to do, it's like what you want to build. And in the verification it's like did we build it right, did we created it correctly or not, it's like verifying the product. And then validating, so did we build the right thing or not. So there is a something, suppose if I take an Apple 16th generation, suppose if I am going to implement launch my Apple 17th device, so 17th should have some specifications or something new. It is validated in a way such that it is going to put in the market. If it is going to the same thing, right, did we build the same the 16, it is very very uncertain that we cannot able to put that one in the market, because it is going to create a mess, because it's not going to useful for anybody. Suppose if I take an example, uh, in the design it is like an writing an ALU RTL. So for creation of a design we are going to use Verilog or System Verilog as a languages. For everything we will use the same one, it doesn't matter. So in the verification it is going to return the test benches for finds ALU bugs. So in the ILU design which might be implemented, there might be some bugs, it will be checked in that. In the validation it is going to be the CPU runs benchmark correctly or not. So these are the some of the major aspects on which we can discuss about the design verification validation as tools. So coming to the industry importance, the design is having the, it's the foundation of the chip development. So it might have the lot of importance. It's a foundation. And come to the verification, it is a 60 to 70% of the total efforts in the VLSI project. Suppose coming to the industry exposure, it's like an how many people. Suppose if I take there are 1 lakh people in the market, like 60 to 70,000 people are working only on this VLSI projects on the verification thing. And the validation, it's the ensures the first pass silicon success and customer satisfaction. So these are like taking the feedbacks from the customers, and from that they are going to validate the things. And balance focus on these three things only will give you high quality product. So we cannot say which is most important, because one is the foundation, one is going to be verified by all the engineers, one is the going to be perfectly given the thing by the audience. Suppose for an automation drone, suppose if I take an example, validation ensures it navigates as real in the environment, not just in the simulation. Even if the code and the hardware work perfectly, it uses find how it out hard to control, it fails validation. Suppose simply we can say design comes first, verification checks you built it correctly or not, validation ends the products whether the user is able to get the high product or not. In summary, it's very simple. The design is going to be implemented on the specs, and the verification ensures the correctness of the device, and the validation whether it is making the real world needs or not, instead of only simulation thing. It's like there is an emulation concept which is the hardware thing which is going to be did for this one. So to ensure, thank you, thank you very much.